Okay, we have this bottle. Let's see where I'm in. Okay, we have this bottle, and it's got a hole in the side. There's a tube, so we can kind of control some aspects of the flow. And we're going to fill it up, and we're going to let water flow out. Okay? Now, I said that originally, right? We're going to fill it up, let water flow out. Okay? Now, if you were paying really close attention, you would have heard flow out, and then you wouldn't have told me what it's going to look like when we fill it up. But that's okay. But you know, it could look like anything when we fill it up. We fill it for a while, stop. Fill it for a while, stop. You can think about what the graph would look like. But what we're focusing on is what it looks like as water flows out. Right? Now, there are two kinds of graphs that I see out there. One of them looks like this. One of them looks like this. Okay? Now there was one, I got to admit, that looked like this. Hey!
Wow.
Okay? Not really. I know some of you were thinking that, but you didn't write it down because you weren't sure. Okay.
That's what my brain looks like. Like my brain activities, that's what it looks like.
Yeah, well, I mean, you know, brain activity can be pretty chaotic.
It's pretty accurate.
Especially if you're up at 2 a.m. investigating the physics of that domino. Okay. It's a great
I tried to
thing.
explain it to my mom, and she was like, you know, this was really cool when my boyfriend back in high school was explaining to me, but it's not the same effect when it's your daughter.
That's pretty good. Okay. Now, which one of these do you think might be valid?
The second one, because that's obviously the right one.
Why do you think the second one?
Because you're
Whoa,
gonna
whoa, whoa. How many of you agree with Isaac?
come on, I've been right.
I love you, Isaac.
There you go.
I don't agree with it.
Oh,
Okay.
You don't need me to prove why I want to
Can we argue? Can we have another argument?
Okay, come on up here and have it out, you two.
Okay.
Go,
No,
Isaac.
you sit down first. I've got to explain myself.
You can go first. I went first last time.
Okay. So,
He'll just
sorry,
prove
I
you
gotta
wrong.
use different things.
Come on.
So,
Grow the community.
like,
Hey.
if you like do this, right?
She's wrong. She's wrong.
You'd see
See her?
that with pressure, that it's gonna.
See her? Right here.
We've seen,
She's wrong. She's wrong.
Hold up. Heather,
I'm picking the second one too.
you are?
Yes.
Dang it. Why do you have to agree with me? I want to argue
You
with you.
agreed with him. We were asking who agrees with Isaac.
I don't know. I'm tired. Leave me
Let me
alone.
just show you. It's the pressure of the water.
Well, that's exactly what I was about to prove. But of course, he had to agree with me. For one
You agreed
point.
with him.
No.
Yes.
No. No.
You just think you didn't. But
You know how? Let me think. You know how when you pop a balloon? You know how when you pop a balloon? Oh my God, that's chalk. Okay, you know how when you pop a balloon, it flies around a whole bunch like this. You know how you do that? It's because there's a whole bunch of air waiting to get out. But once you hit a certain point, it just kind of flops on the ground, and it becomes a piece of plastic. So it's going to be the pressure exerting itself on this. And see, this would be the asymptote. So you're going to have a certain point where it's just not even, it's just going to barely trickle out, and it's just going to stop. And you will not be able to go underneath that.
Yeah, there's a key.
Yeah,
Pressure of the
Isaac.
water. Now let's make another connection here. Okay? What does the pressure of the water do to the flow? What's the flow going to look like as a result of?
It's going to go like this.
Okay, why?
Because it's going to be pushing it out. Because of the way, let me find it. It's gonna, because like the little tube on the end of it.
It's like, okay, if I were to step on his head, right? Just
It's
if I were to step on his head, all the blood and everything would fall out really fast at first, but once there's less there and I put less pressure because there's less there, it would start to slowly come out.
Yeah, is that related to cardiovascular surgery?
A little bit, a little bit.
Oh, a lot of pressure stuff there, right?
Yeah.
That's really important.
See?
Okay.
I got this.
You love geometry, you love shapes, you want to be a cardiovascular surgeon, this is a good exercise for you.
There we go.
Okay? Okay, well,
I'm always right.
the point is, then,
I wanna
what's going to happen that you could actually measure, it's related to the pressure as the water flows out. Now, what we have, okay, in this container, around this point here becomes a uniform cylinder, right?
see.
Okay, uniform cross-sectional, which is a circle, same size all the way down. That's not actually strictly true. The thing will tend to bulge a little bit due to pressure, but these things are actually pretty tough. It's very difficult to make them bulge. So this constitutes really a pretty good uniform cylinder, okay? So, we've got a uniform cylinder, and we've got water. Now, what color is water? Well, it's clear, but because of various effects, it can appear blue. So we got some nice blue water from the ocean, because everybody knows the ocean water is blue, right?
No,
Yeah.
it's not.
It's purple,
It's
but they
totally-
flavored it.
Okay, well, and how do we know that this is water?
Because of the blue line.
Because of the shark fin.
Oh!
We're
Wait,
gonna
are we
need
gonna kill the shark? Because once we drain it out, it's not gonna be able to breathe.
Remember, there's a little.
A
bit
shark
at the
will just
bottom.
go out with the water and, you know.
No, but
it's
Sharks are
gonna
pretty
be
adaptable,
We're
you know.
gonna need a bigger 2-liter bottle.
A shark could kill it. Like if you
Well,
put a
these
shark
are-
in
these
too
are
small
mini
of a
sharks.
space, it'll die. Because
Yeah.
it gets oxygen by like leaving its mouth open and swimming, and it
You know,
goes
if I
through
could
the
was
be any
expecting to,
shark,
like,
I would
flop
want to be a
around
bull
and
shark
awkwardly
because
slap
that means
my
I
hand.
could live basically wherever I want, and I could eat people all over the world.
That's
kind of
true.
messed
I'd be a
up.
whale shark.
Yeah, but you
I
couldn't
wanna
eat
take
clowns
it to
because they
space. Somebody
taste
starts it.
funny.
Someone starts it. Over. Just like bump into one.
Wait. What would you say when you ate the clown? Yeah.
Oh, this video.
Get
Dude,
it.
that kid that said that thing about the
Somebody
shark.
get rid of him. Okay. Oh,
Can I
focus
get
back.
that
Focus back, this is important. Okay, so what happens when you take your thumb off of this hole? Water
Oh, just
flows out,
oh my God.
okay? What shape does this make?
Makes like
A parabola.
It's a parabola, actually, or very close. There's some air resistance involved. There are little shark fins sticking out of the water that flows out. Okay, because there are sharks everywhere, right? Sharks live in water, so there must be sharks in the water we drink. They must be small because we can't see them. Now,
maybe they're eating the cancer cells inside of us.
how is this picture going to change when the water turns purple as it gets down here?
It's gonna make an even longer parabola.
No, it's not, because the pressure's low.
It's gonna make
It's
it. No,
gonna
I'm
make a
saying.
shorter one.
I'm saying it's gonna be like as
It's
in
gonna
like
go, it
long.
was like this, right, and now it's gonna be like that.
Let
Because
let me
the
draw it
pressure's
out
lower.
before we fight. Let's draw it out. It's gonna be
Dude, you just said.
longer.
You
No,
just
that's
said
what
that
it's called.
gonna be
That's
on
what.
farther out.
I said that
Yeah.
it says it's gonna be longer.
How is it gonna be longer?
That's what it's called in
Oh,
algebra
right.
2.
Okay,
Fight me, just because
Hey,
I haven't been
hey,
in algebra 2
okay.
doesn't mean I know what I'm talking about.
this is good. Okay, everybody agree it's going to look more like this?
Yeah.
Okay, why? Because there's less pressure pushing the water out, so it's not going to go as fast. Okay? Now, there are several really neat things about this. One is, Isaac mentioned the word longer. Okay? I'm not sure what he meant by that. It's okay, but we could test this. If we knew what this shape is, we could do a trapezoidal approximation graph, and we could calculate the lengths of all the hypotenuses.
Well, wouldn't it still be a parabola? It would just be a weaker one.
It will be a parabola, or very nearly a parabola. In an ideal situation, with an ideal fluid, when you have no air resistance, that would be. But if you have no resistance, you have no air, so the water boils, so that kind of breaks down. Okay,
But if this one was like x squared plus x plus 1,
It's just a source.
this one would be like negative x, and then this one would be y. This one would be like negative like 3x squared plus x plus 1. I'm saying like it would,
Hey, guess what?
Straight
You're
as a
wrong.
line.
if you graphed it like this,
Circle.
Made my way back around.
and this one would be higher than this one. Yeah.
But why would it be
Fred was
going that
actually
way? It'd
upside
be-
down.
You'd be taking it, the maximum would be up here, not the minimum would be down there.
I flipped it.
Learn how to do,
He flipped the graph. Gee.
but he
Flip
said
the
that, he said you were wrong, so.
No, I didn't say he was wrong. I said this is really good.
Oh!
Okay?
Oh!
And you're going to solve simultaneous equations to figure out things like this. Okay?
Yeah.
Using matrices and inverse matrices and Wolfram alpha.
Don't look at me.
You also be expected to do it the long way by just eliminating variables from the equation. Okay?
Correct the graph.
Now,
It wouldn't be like that.
It would not be like that.
Yes, it would. Yes, it would.
yeah, very good. Okay.
She's wrong again.
Give me my hat back.
What
We'll
is it?
continue in a second.
What is it now? 21.